Negative exponents will give us reciprocals. That's their definition. Over here I've written on the board 3 to the negative second power, and we want to simplify this, meaning we want to write it without an exponent or with a positive exponent. By definition, 3 to the negative second power is 1 over 3 to the positive 2. Now, 3 to the positive 2 is 9, so I end up with 1/9. So 3 to the negative 2 comes out to be 1/9, and you can see my negative exponent gives me a reciprocal. Here's our next one. 5 to the negative 3, likewise, is going to be 1 over 5 to the positive 3. Now I can take 5 to the third power. 5 times 5 is 25, times 5 again is 125. So you see again, I get a reciprocal for 5 to the negative third power. Now let's try some other properties of exponents that have to do with division. How about if we have x to the 10th divided by x to the 4th? I have division with the same base. My properties of exponents tell me that that always results in subtraction of exponents. So let me write my base as x to the 10 subtract 4. I introduce the subtraction sign myself. The exponent in the numerator always comes first, the exponent in the denominator second. 10 subtract 4 is 6, so I have x to the 6th power. I'll move right over to this problem, 5 to the 1 divided by 5 to the 3. Same type of problem, 5 to the 1 subtract 3. I introduce the subtraction sign myself because it's division with the same base. Exponent in the numerator first, exponent in the denominator second. That's 5 to the negative 2 because 1 plus negative 3 is negative 2. Using my definition for negative exponents, that's 1 over 5 squared, which is 1 over 25. So I end up with a negative exponent right here, and I use the definition of negative exponents as giving me reciprocals to write 1/25. 2 to the 5th power divided by 2 to the negative 3rd power. That'll be 2 to the 5. Subtract, because it's division, the exponent in the denominator, which is negative 3. So that exponent in the denominator is negative 3. I have to write that second after the subtraction sign that I introduced myself. So that's 2 to the 5 plus 3, because subtracting a negative is the same as adding its opposite, which is positive. 2 to the 8th power, and I'm just going to leave it like that. I won't simplify it. So that's what we do with division with the same base. We subtract exponents. Sometimes that exponent comes out to be negative, and that gives us a reciprocal. I want to simplify this expression, a to the 3rd squared, a to the 4th to the 5th, all divided by a to the 5th squared. I'll start by taking this power raised to another power. That will be a to the 6th times a to the 20th when I multiply exponents, divided by a to the 10th when I multiply exponents there. In the numerator, I have multiplication with the same base, so I add exponents and get 26. In the denominator, I still have a to the 10th. Subtracting the exponent in the denominator from the exponent in the numerator, I end up with a to the 16th power. So, fairly complicated expression, simplifies down real nicely using those properties of exponents. Here's a quick look at scientific notation. 4.23 times 10 to the negative 3rd power. I want to write that in expanded form. Remember, this is 4.23 times 1 over 10 to the 3rd, because negative exponents give me reciprocals. That's 1 over 1,000. When I divide 1,000 into 4.23, it's going to move the decimal point over this way 3 places. So I'm going to have 0.123 places, 23. So that's the expanded form of this number that's written in scientific notation. Now let's take this number and write it in scientific notation. I'm going to move the decimal point over 1, 2, 3, 4 places, so I get a number between 1 and 10. That'll be 3.57. I multiply by a power of 10 so that this number comes out to be equal to this number. I look at it this way. Here's a small number. I made it larger when I wrote it as 3.57. I've got to multiply by a small number to make up for it. I moved the decimal point over 1, 2, 3, 4 places. So I'm going to multiply by 10 to the negative 4th, which is a small number. So back and forth between scientific notation in expanded form using the numbers that have negative exponents.
This problem asks, what are the 2 square roots of 64? So the first thing we're going to need to do is take the square root of 64, which gives us 8. But we notice that if we square negative 8, we get 64 as well. So our two square roots of 64 are going to be positive and negative 8. And that's our answer.
This problem asks us to do some simplification dealing with scientific notation. What we have is 6.8 times 10 to the 5th times 3.9 times 10 to the negative 7 all over 7.8 times 10 to the negative 4. So what we need to do is we need to combine these two scientific notation numbers in the numerator, and then we can divide that from the denominator and get our simplified form. So first what we're going to get is we need to rearrange this so we get 6.8 times 3.9 times 10 to the 5th times 10 to the negative 7th all over 7.8 times 10 to the negative 4. Well, when you multiply 6.8 times 3.9, you're going to get 26.52. So you're going to get 26.52 times, well, 10 to the 5th times 10 to the negative 7, that's going to be 10 to the negative 2 times 10 to the negative 2, all divided by 7.8 times 10 to the negative 4. Now we need to divide this, so this is equal to 26.52 all over 7.8 times 10 to the negative 2 over 10 to the negative 4. Now from here, 26.52 divided by 7.8, that's going to be 3.4. So this is equal to 3.4 times, now when you do this division here, 10 to the negative 2 over 10 to the negative 4, what you do is you subtract the exponents, since the bases are the same, of 10, so it's negative 2 minus a negative 4. So negative 2 minus negative 4, negative 2 plus 4 is going to be 10 to the 2. So times 10 squared for the final answer.
We are asked to simplify 6.8 times 10 to the 5th times 3.9 times 10 to the negative 7 all over 7.8 times 10 to the negative 4. So first we're going to separate our numbers 1 through 10 from our powers of 10. So we get that this is equal to 6.8 times 3.9 all over 7.8. We're going to multiply this by our 10 to the 5th times 10 to the negative 7 all over our 10 to the negative 4. So we get that this is equal to 6.8 times 3.9 will give us 26.52 over 7.8. Simplifying that, we get that this is equal to 3.4. Now moving on to our next step, we have this times 10 to the 5th times 10 to the negative 7. Since we're multiplying, we're going to add our exponents. So we get 10 to the negative 2 all over 10 to the negative 4. So we're going to times this by 10. And we're going to figure out what our exponent is. So since we are dividing, we're going to subtract. And negative 2 is greater than negative 4, so we're going to subtract negative 4 from negative 2, which will give us negative 2 plus 4, which will give us a positive 2. So we get 3.4 times 10 to the second.
For this problem, we're asked to simplify a to the third squared, a to the negative fourth, divided by a to the negative fourth cubed. So first, let's simplify. So we'll multiply these two together. So we'll have a to the sixth, a to the negative fourth, and then we'll multiply these two together. We get divided by a to the negative 12. Next, we're going to add the exponents. So we have 6 plus negative 4 gives us a squared. And then we'll bring this exponent up to the, or this term up to the top because it's a negative. So we'll have a to the 12th. And then again, we'll add the exponents. So we will end up with a to the 14th. And that's our answer.
We want to simplify x to the negative 8 times x to the 5th. So notice that we have the same base. Our base is x, and we're multiplying, so we want to add the exponents. So this is equal to x to the negative 8 plus 5. So negative 8 plus 5 is negative 3. So this is equal to x to the negative 3. We want our final answer without negative exponents. So we can think of this x to the negative 3 as being equivalent to 1 divided by x to the positive 3. So x to the negative 8 times x to the 5th is equivalent to 1 divided by x to the 3rd.
For this problem, we're asked to simplify a to the third squared, a to the negative fourth, divided by a to the negative fourth cubed. So first, let's simplify. So we'll multiply these two together. So we'll have a to the sixth, a to the negative fourth, and then we'll multiply these two together. We get divided by a to the negative 12. Next, we're going to add the exponents. So we have 6 plus negative 4 gives us a squared. And then we'll bring this exponent up to the, or this term up to the top because it's a negative. So we'll have a to the 12th. And then again, we'll add the exponents. So we will end up with a to the 14th. And that's our answer.
We want to simplify x to the negative 8 times x to the 5th. So notice that we have the same base. Our base is x, and we're multiplying, so we want to add the exponents. So this is equal to x to the negative 8 plus 5. So negative 8 plus 5 is negative 3. So this is equal to x to the negative 3. We want our final answer without negative exponents. So we can think of this x to the negative 3 as being equivalent to 1 divided by x to the positive 3. So x to the negative 8 times x to the 5th is equivalent to 1 divided by x to the 3rd. In this example, we want to simplify 3x to the 5th raised to negative 2. So we can think of this 3 as being raised to 1. And now I'm going to distribute this negative 2 to 3 raised to 1 and x raised to 5. So when we're distributing exponents, we want to multiply the exponents. So 1 times negative 2 is negative 2, so this becomes 3 to the negative 2 times x, and 5 times negative 2 is negative 10, so x to the negative 10. So notice that both the 3 and the x are raised to negative exponents. So we can just think of this as 1 divided by 3 to the positive 2 times x to the positive 10. In this example, we want to simplify y to the 5th divided by y to the 3rd, all raised to 2. So first I'm going to distribute this 2 to the numerator and denominator. So when we're distributing exponents, we want to multiply. So this becomes y to the 5 times 2, which is 10. So y to the 10th divided by y to the 3 times 2, which is 6. So divided by y to the 6. So notice how we have the same base. Our base is y. So when we're dividing the same base with exponents, we want to subtract the exponents. So this is equal to y to the 10 minus 6. And 10 minus 6 is 4. So this is equal to y to the 4th. So y to the 5th divided by y cubed, all squared, is equal to y to the 4th. In this example, we want to simplify x to the negative 8 divided by x squared to the 3rd. So first I'm going to distribute this 3. So this becomes x to the negative 8 divided by x to the 6, since 2 times 3 is 6. So notice we have the same base. Our base is x. So we need to subtract the exponent since we're dividing. So this is equal to x to the negative 8 minus 6. So negative 8 minus 6 is negative 14. So this is equal to x to the negative 14. And we want our final answer without negative exponents. So x to the negative 14 is equivalent to 1 divided by x to the positive 14. So x to the negative 8 divided by x squared raised to the 3 is equal to 1 divided by x to the 14th. In this example, we want to simplify 2 to the negative 3, 5 to the negative 2, and 3x to the negative 6. So whenever we have a number or a variable raised to a negative exponent, that's the same as if we did 1 divided by whatever that number was to the positive exponent. So we had 2 to the negative 3, so that's equal to 1 divided by 2 to the positive 3. Then we can just simplify from there. 1 divided by 2 to the 3rd is 8. So 2 to the negative 3 is 1 divided by 8. In part B, we have 5 raised to the negative 2. So that's equivalent to 1 divided by 5 raised to positive 2. And 5 squared is 25. So 5 to the negative 2 is 1 divided by 25. Next we have 3x to the negative 6. So notice that just x has the negative exponent. So 3 is going to be in the numerator still, since 3 is not raised to a negative exponent. And this x to the negative 6 becomes x to the positive 6 in the denominator. So 3x to the negative 6 is equivalent to 3 divided by x raised to 6.
For this example, we'll simplify as much as possible 9 to the negative 3 halves. First thing we're going to do is rewrite this as 3 squared to the negative 3 halves. This is going to be equal to 3 to the 2 over 1 times negative 3 over 2. We can see that both 2's will cancel, so that we're left with 3 to the negative third. Now, since it's a negative exponent, we have to rewrite this as 1 over, and 3 cubed is going to be 27. So our answer is 1 over 27.
Alright, in this example we want to simplify the following expressions. And remember, if you have a negative exponent, it actually can be written as 1 over what that is, so 2 to the third. And we just simplify it that way. And 2 to the third is 8, so this is 1/8. And this is also 5 to the negative 2, so we just write that as 1 over 5 squared. 5 squared is just 25, so this is 1 over 25. And our last one, we have a 3 times x to the negative 6. So we can rewrite this as 3 over x to the 6 to get rid of the negative exponent. And we can't simplify that any further, so that looks like our answer right there.
For this example, we'll simplify as much as possible 9 to the negative 3 halves. First thing we're going to do is rewrite.
We want to simplify 27/8 raised to negative 4/3. So if I have a number, let's say a, we raised to a negative exponent, let's say negative 1/3. By definition, this equals 1 divided by a raised to the positive exponent. So going back to our example, 27/8 being raised to negative 4/3, well that's just equal to 1 divided by 27/8 raised to positive 4/3, which equals 8/27 raised to 4/3. So a shortcut is whenever you see a number being raised to a negative exponent, just flip that number like we did here and then raise it to the positive version of the exponent. So let's write this in root form. So whatever number is in the denominator, that's what type of root it's going to be. So it's going to be a cube root. And then the number that goes inside is this number raised to the numerator. So 8/27 raised to the 4th. And I'm going to write out what this is. This equals the cube root of 8/27 times 8/27 times 8/27 times 8/27. So 8/27 to the 4th power. So we're taking a cubed root. So it looks like right here I have a group of 3. So I can pull out 8/27s from that group of 3 outside the cube root. And then I'm left with the cubed root of 8/27s. And we can write this as 8/27s times the cubed root of, well, 8 is equal to 2 times 2 times 2. And 27 is equal to 3 times 3 times 3. And so since I'm taking the cubed root, I have a group of 3 2's right here, and a group of 3 3's right there, so I can pull those out. So really what we have is 8/27 times, I pull out a 2 in the numerator, and I can pull out 1 3 in the denominator. denominator, and then I left with nothing inside the cube root. 8 times 2 is 16, and 27 times 3 is 81. So 16 divided by 81 is our final answer. So 27/8 raised to negative 4/3, that's the same thing as 8/27 raised to positive 4/3. And 8/27 raised to positive 4/3 is the same thing as the cubed root of 8/27 raised to the 4th power. And when we work that out, we find out that the cubed root of 8/27 to the 4th power is the same thing as 16 divided by 81. In this example, we want to divide 15x cubed by 3x squared, and we also want to divide 39x squared y cubed by 3x y to the 5th. So notice that I've written the numbers in green, the x terms in black, and the y terms in blue. So in part A, we have 15x cubed divided by 3x squared. So first I'm going to divide the numbers. So 15 divided by 3 will leave us with a 5 in the numerator. And then we have x cubed divided by x squared. So when we're dividing the terms the same bases and they have exponents, we want to subtract the exponents. So 3 minus 2 is 1. So we'll get x raised to 1. And we can just write that is 5x. So 15x cubed divided by 3x squared is 5x. On part B, we have 39x squared y cubed divided by 3xy to the 5th. So first, 39 divided by 3 will leave us with a 13 in the numerator. X squared divided by x, we can think of this x as being raised to 1. So we're dividing, so we want to subtract the exponents. So 2 minus 1 is 1. So x raised to 1. And then y cubed divided by y to the 5th. We want to subtract the exponents. So 3 minus 5 is negative 2. So y raised to negative 2. So we want our final answer without negative exponents. So we can write it as 13, and x to the first, we can just write that as x. Divided by, so we put y in the denominator since it has a negative exponent, and instead of being negative 2, now it's positive 2. So 39x squared y cubed divided by 3xy to the 5th is 13x divided by y squared.